All right, so you know how a bird can just like zip through a forest, dodging branches like it's nothing? It's kind of mind-blowing how they navigate those cluttered spaces at crazy speeds.
Right.
And that's exactly what got me so fired up about the research article you sent over. It's all about this new autonomous aerial vehicle they're calling Super,
Well, yeah.
short for Safety Assured, High Speed Aerial Robot. Seriously, the name alone sounds like straight out of sci-fi movie.
Well, it kind of is straight out of sci-fi, isn't it? It's not just about like copying what birds do, you know? It's Super's really pushing the limits of what we thought robots could handle.
Totally. So for this deep dive, let's strap ourselves in and explore the world of cutting-edge robotics. First, we'll break down how this super thing achieves those insane speeds while somehow staying safe. And then we'll see how all of this could actually play out in the real world.
Yeah, that's the exciting part. It's, we're not just talking theory here. This thing, like, actually flies.
Wait, really? Before we get to that, the article mentioned Super being surprisingly compact.
Oh, yeah, it's tiny. It has a wheelbase of just 280 millimeters.
Wow.
To put that in perspective, that's smaller than a DJI Mavic 3 drone, which is already pretty small.
Yeah.
But here's the kicker. It boasts a thrust-to-weight ratio greater than 5.0.
Hold on, a thrust-to-weight ratio of 5. Okay, non-engineer brain here. What does that actually mean? Like, if I was riding on this thing, what would it feel like?
Think of it this way. Imagine the feeling of being pushed back in your seat when a sports car takes off from a standstill.
Okay.
That's the kind of power we're talking about here. That ratio means the thrust generated by its motors is 5 times greater than its own weight. Even an F-35 fighter jet has a thrust-to-weight ratio less than 1.
Oh, wow. So it's like little rocket with propellers. That's wild. But being small and powerful is only part of the equation. It needs to see where it's going, right? What kind of system does it use to perceive the world around it?
That's where Super gets even more interesting. Instead of relying solely on cameras like many drones do, this thing uses a lightweight 3D LIDAR sensor as its primary way of seeing.
LIDAR. Okay, so it's not just taking pictures, it's actually mapping the environment in 3D.
Exactly. And this LIDAR can detect obstacles up to 70 meters away.
Wow.
Which is a massive advantage over those vision-based systems that usually only have a much shorter range.
Okay, I can see why that long-range detection would be super important, especially if you're moving at those kinds of speeds.
Yeah, think about it, right? You need as much time as possible to react and avoid obstacles. When you're flying that fast, a split-second delay could be disastrous.
Makes sense. So the LiDAR is basically giving Super that extra time to make decisions. Speaking of decision-making, the article also mentioned that current autonomous drones struggle to find that sweet spot between speed and safety. What are some of the biggest challenges they face?
Well, there are basically two camps when it comes to autonomous drone navigation. You've got systems that prioritize speed above everything else. They just assume that any unknown space is free and clear, which is like a recipe for disaster, especially at high speeds.
Yeah, that sounds a little reckless, especially in a complex environment like a forest.
Right. And then you have systems that are super cautious and put safety first. But the trade-off is that they end up being slow and clunky.
So it's like this constant tug of war between speed and safety.
And that's precisely what makes Super so groundbreaking. It manages to pull off both high speed and a high level of safety assurance.
Okay, now I'm really intrigued. How does it do that? What's the secret sauce?
It all boils down to something called two-trajectory planning. Super doesn't just plan one flight path, it plans 2 different paths simultaneously.
Hold on, 2 paths at once. That sounds a bit complicated.
It is, but in a brilliant way. You've got the exploratory trajectory, which is all about maximizing speed. It assumes that those unknown areas are free of obstacles, at least for the moment.
So it's like saying, let's gun it until we see a reason not to.
Pretty much, yeah. But here's where it gets clever. At the same time, it's also calculating a backup trajectory. This path is all about safety. It stays within the known safe zones, ready to be activated the second the exploratory path encounters any trouble.
So it's like having a plan B ready to go at a moment's notice. That's pretty slick.
It really is. And Super doesn't just randomly switch between these 2 paths. The system is constantly evaluating the situation and calculates the optimal time to switch, ensuring maximum efficiency. This is a major factor in how it maintains those high speeds without compromising safety.
So it's almost like Super is thinking ahead, anticipating potential issues before they even arise?
In a way, yes. And there's another aspect that makes this whole system even more impressive. Most autonomous systems use these complex maps called occupancy grid maps, but those maps require a ton of processing power.
So how does Super handle that mapping challenge?
Instead of those computationally expensive occupancy grids, it uses something called a point cloud map, which is built directly from the LIDAR data.
Okay, and why is that a big deal? What's the advantage of using this point cloud map?
It's all about efficiency. Point cloud maps are much faster to process, which is essential for real-time mapping and planning over longer distances. Without that speed, maintaining those high speeds would be impossible.
Right, it needs to be able to think and react quickly to keep up with its own speed. So it's not just about seeing what's there, it's about understanding how that environment is changing in real time.
Absolutely. But wait, there's more. Super's map also includes a clever time decay mechanism.
A time decay mechanism, what's that all about?
Well, think about a moving object, like a bird or another drone passing through Super's field of view. A traditional point cloud map would mark that space as occupied, even after the object has moved on.
Right, kind of like a phantom obstacle.
Exactly. But this time decay feature basically allows the system to forget about those temporary obstacles, ensuring that it doesn't get confused by things that are no longer there.
That's pretty smart. So to sum it up, we've got this incredibly nimble, powerful drone with advanced sensing capabilities and a super smart planning system. But does it actually work in practice? Does it live up to all the hype?
Now, you might be thinking, okay, this all sounds great in theory, but does it actually work? Well, get this.
Wait, are you about to tell me they actually tested this thing in the real world?
Oh, they went all out. And the results? Let's just say Super didn't disappoint.
All right, spill the beans. What happened when they let Super loose in the real world?
First, they ran a bunch of simulations. Super, aced those with a near-perfect success rate,
Yes.
99.63%.
Wow.
And it wasn't just safe, it was blazing fast. It consistently outperformed other cutting-edge planning methods, things like the bubble planner Raptor and faster, across all sorts of obstacle courses.
So it's not just playing it safe, it's actually faster than the competition. Color me impressed.
Oh, it gets better. We're talking about a reduction in mission failure rates by a factor of 35.9 to 95.8 times compared to those other methods. That's not just an improvement, that's like a whole different league.
Wow, those numbers are mind-blowing. But simulations are one thing.
Yeah.
How did Super fare when they took it out of the lab and into the real world?
They took Super to a forest, like trees, branches, uneven terrain, the whole shebang. And they didn't go easy on it. They tested it in all sorts of lighting conditions, broad daylight, dusk, even pitch black night.
Okay, so they really threw everything they could at it. What happened? Did Super rise to the challenge?
It blew the competition out of the water. They got it flying at over 20 meters per second through dense foliage, dodging obstacles like it was, born to do it. They even pitted it against a top-of-the-line commercial drone in a super cluttered environment. Super navigated it flawlessly, while the commercial drone got completely stuck.
Hold on. 20 meters per second? That's incredibly fast, especially in a forest. And it did all that while maintaining that, a perfect safety record.
That's the thing. Not a single crash in any of the real-world tests. 100% success rate.
Yeah.
They even strung up thin wires, power lines, which are notoriously difficult for drones to detect. Yeah. Some of them were as thin as 2.5 millimeters in diameter.
So, barely thicker than a strand of hair.
Yeah, pretty much. And Super dodged every single one. It really shows how that LIDAR system and that sophisticated planning algorithm will work together.
It's amazing how it can see things that small while moving that fast. It really pushes the boundaries of what we thought autonomous drones were capable of. But the article hinted that Super's potential goes way beyond just navigating obstacles. What else can it do?
You're right. The researchers have already successfully used Super for other tasks like object tracking and autonomous exploration.
Object tracking, so it could follow a moving target. That sounds incredibly useful.
They actually tested it out by having it follow a person jogging through the forest, and even a car driving on a village road.
Wow, imagine the possibilities for something like wildlife monitoring. You could track an animal's movement through dense jungle without disturbing it, or even use it for search and rescue in disaster zones. A drone that can follow a subject through challenging terrain without putting itself or anyone else at risk. That's a game changer.
Absolutely. And then there's autonomous exploration. The researchers sent Super out to map a large area that was completely uncharted. They gave it specific waypoints to hit, but it had to figure out the best way to get there.
Yeah.
and maximize the amount of new information it gathered.
So it's not just blindly following a pre-programmed route, it's making decisions on the fly to efficiently explore its surroundings. That's wild.
Right, it's like sending out a robotic explorer. Super speed, agility, and advanced mapping capabilities make it perfect for exploring places that might be too dangerous or difficult for humans to reach. Think about, like, a collapsed building after an earthquake, or a dense jungle environment. Super could map those areas quickly and safely, giving rescuers or researchers valuable information.
That time decay feature you mentioned earlier, the one that helps Super ignore those phantom obstacles, how does that come into play in these real-world scenarios?
It's a crucial part of what makes Super so adaptable. Think about a search and rescue mission in a crowded city. You've got people, cars, all sorts of things moving around. A traditional point cloud map would be constantly tripping over those moving objects, treating every space they pass through as an obstacle.
Right. It would be like trying to navigate a crowded room with your eyes closed, bumping into everything.
Exactly.
Yeah.
But Super's time decay feature lets it forget about those transient obstacles, so it can use that space efficiently. It's like it's learning and adapting in real time.
They must have tested that ability to handle dynamic environments, right?
Oh, yeah. They had Super navigating a space. While two people were just walking around randomly, getting in its way, Super weaved around them flawlessly, even using the paths they had just walked through, without a single collision. It really shows how robust and adaptable this thing is, even when things are constantly changing around it.
So we've established that Super is an incredible piece of engineering, achieving things that were previously thought to be impossible. But let's get real for a second. Every technology has its limitations. What are some of the areas where Super could still improve?
That's a great question. It's important to remember that no technology is perfect. While Super's LIDAR is smaller and lighter than previous versions, it's still bulkier and heavier than a simple camera.
So there's still room for improvement in terms of shrinking it down even further.
Absolutely. The smaller and lighter you can make the drone, the more agile it becomes, and the more potential it has to navigate even tighter spaces. And while Super can handle dynamic environments pretty well, it doesn't actually predict the movement of those objects.
So it's reacting to changes rather than anticipating them.
Exactly. It's more of a reactive system right now. If it could predict the movement of objects, it could plan even safer and smoother trajectories. That's something the researchers are already looking into for future development. And of course, there's always the push for even faster processing speeds and more efficient algorithms.
Well, considering everything Super can already do, I can't wait to see what the future holds for this technology. What does Super's success tell us about the current state of robotics? Where do you see this field going in the next few years?
What strikes me about Super is that, it's like a bridge between theoretical research and real-world applications. This isn't just a cool concept anymore. It's a working system that's already proving itself in complex, unpredictable environments.
So it's a sign that robots are moving out of the lab and into the messy real world.
Exactly. And I think we're going to see that trend accelerate in the coming years. Robots are becoming more adaptable, more robust, and more capable of operating autonomously in complex environments.
It's almost like they're becoming more intelligent.
Well, intelligence is a complex term. But, it's clear that robots are becoming more sophisticated in their decision-making and problem-solving abilities. Super is a prime example of that.
It makes you wonder what kinds of applications will emerge as this technology continues to evolve.
That's what's so exciting about this field. We've only scratched the surface of what's possible with autonomous systems like Super. Think about things like, search and rescue missions in disaster zones, delivering medical supplies quickly and efficiently, inspecting infrastructure in hazardous areas, monitoring the environment. The possibilities are endless.
It sounds like we're standing at the edge of a robotic revolution.
I think that's a fair assessment. And it's happening faster than most people realize.
We've covered a lot of ground today, from the nuts and bolts of Super's design to the mind-blowing implications for the future of robotics and how it could change our lives. This has been a truly fascinating deep dive.
Yeah.
Any final thoughts you want to leave our listener with before we wrap up our deep dive into Super?
It's really about understanding the principles of agility, perception, and intelligent decision-making that allow birds to navigate the world so effortlessly.
So it's about taking inspiration from nature and using it to create technology that can, benefit humanity. That's a pretty awesome thought.
Absolutely. And for me, that's the most inspiring part of this entire field.
It really makes you appreciate the incredible complexity of nature and the brilliance of the researchers who are working to unlock its secrets. But speaking of brilliance, there was one point in the article that really caught my attention. It mentioned the potential for super to be used in search and rescue missions.
Right. We touched on that briefly, but it's worth diving into a bit deeper. Imagine a situation where, like, a natural disaster has just struck,
Yeah.
and it's too dangerous for human rescuers to enter, like a collapsed building, a landslide, a flooded area, anything like that.
Where every second counts.
Right.
And any delay could mean the difference between life and death.
Exactly. Now imagine you could send in a drone like Super, equipped with advanced sensors, and capable of navigating those incredibly complex environments at high speed.
It could quickly survey the entire disaster zone, pinpoint the locations of survivors, and relay that critical information back to the rescue teams.
Right. And because it's so agile and can handle those, like, tight spaces, it could even deliver emergency supplies or medical equipment to people who are trapped or injured.
Wow, that would be a complete game changer for disaster response. It could drastically increase the chances of survival and help rescue teams use their resources more effectively.
And, like, think about the psychological impact too, even in the most desperate situations. Knowing that a drone is out there searching for you, doing everything it can to reach you, could provide a glimmer of hope.
It's like a little robotic guardian angel, bravely venturing into places where humans can't go.
I love that analogy. It really highlights the human element that often gets overlooked. When we talk about technology, it's not just about building cool machines. It's about how those machines can be used to help people in need.
That's a great point. Technology is at its best when it's used to make a positive impact on the world.
I completely agree.
Well, you've given us a lot to think about today. From the technical wizardry behind Super's design to the mind-blowing implications for the future of robotics and how it could change our lives, this has been a truly fascinating deep dive.
Yeah, it's been great chatting.
I'm sure our listeners are feeling as inspired as I am right now. We've learned so much about Super and what it represents for the future of autonomous systems. What other applications can you imagine for this kind of technology? What problems could it help us solve? The future of robotics is wide open, full of possibilities, and it's up to all of us to explore them.
Absolutely. That's the beauty of it, isn't it? The possibilities are truly endless.